So I want to talk about doing Wi-Fi in slow and very fast trains. Yeah, we really have trains that go above 185 miles an hour. And what we're doing there is basically we're using totally different gear than we all used to. This starts with this cable. This is why I brought it. We all know this RJ45. We're using different connectors. So let's go into the loophole, yeah, or in the rabbit hole of the magic M12 connector world. We run on a totally different vendor set. Raise your hand if you know more than 2 vendors of this. Okay, we got a few, yeah? But this is not the regular gear we're used to, yeah? We're using the same protocol that what Peters was talking about, but we're opening it up for any device, any person traveling in a railroad. So you could come from Australia, visiting Germany, or you could come from America, or from wherever in the world. And we need to support it. Do we want that? Yes, because it must be easy and frictionless. Yeah? So here's one variant what we can do. So we put in an amplifier, we put in a signal repeater, and we have a leaky cable, and we're just repeating the mobile signal without Wi-Fi at all. Will this make foreign visitors happy? Maybe not, because they maybe not have a data plan. So they're not really happy with that. And even this gear is complicated, and we all know leaky cables don't do MIMO. Modern mobile networks need MIMO. So that's not the best solution. And then we have the problem of moving. I visualized that. The train is moving. So basically, I made the base station move, okay, but it was easier to visualize that way. Now imagine this doing much, much faster. So how would you get the signal into the train? Because it's a large, thick metal pipe. So one trick is we sweeten the glass so that we can get more signal into the trains. So this is what Germany, Switzerland, and many other countries are doing now. And we developed the process how to do that. It's not that complicated like it looks. It's doable, but we're here for something different. Yeah? So why do we do Wi-Fi? Why do I choose this old guy? Because it's going back in time. The idea was to create one big pipe and use all mobile signals we can get from all providers we could get with several antennas on the roof and distribute the signal via Wi-Fi to all the end devices. So then we don't depend on this windows and all the mesh and the handover. So then we can have 10 antennas on the roof and some access points in the train. How hard can it be? Okay, this is a pretty new report from Ookla. And this is what you can expect with this one large pipe. Sweden is in the lead, okay, I get the point. But hey, wouldn't we expect more? It's just 60 megabits in peak. Is that all that this train system can deliver? Or is it just a mobile network? What's the problem? I brought one device. This is Wi-Fi 5. This is one of the newer ones that's out in the field. There's no Wi-Fi 6 trains really out there. Yeah? So this is old equipment because the life cycles are totally different. The train must run for 30 years plus. And you maybe get a hardware refreshment every 10 years. And if config management, this is for the Cisco guys, it's more AeroNet style than anything else. If you're happy, it's more iOS style than anything else. Now they're coming along and seeing, okay, we get this thing of wireless controllers and there could be a benefit. So Wi-Fi 4, Wi-Fi 5 is a standard, but we still must support all devices, an iPhone 17. And then comes the other guys, oh, the money, money. We just have the train ticket and Wi-Fi is just one other service on it. And to place hardware in the trains is very difficult. If you got space for this, imagine how big the newest Cisco is, or the biggest whatever. The new access points are much bigger. You don't have the space to put it. And this is the rules. You have to obey at least 5 or 6 of them, maybe not all, but they're not heard in the office space. This is not a comprehensive list. Don't get me started on that. Yeah? And just to show you some gear. So the other one is a new variant of this one. It's twice as large. The other one doesn't look so nice in a train. So what do? We invent some covers so it looks nicer for the indoor, as I think everybody knows this aesthetics problem with Wi-Fi APs. Nobody should see them, but they should work great. And then, what did we expect? One access point covers 1 or 2 train cars, maybe 3, we don't know. You ask the people, nobody measured. So we measure, and that's it. It's 70 to 80% of one train, which is 250, 300 meters, with one single AP, this old guy. And then what do? All what we learned in the last 10 talks. We're optimizing the network with the old school stuff. And then we get, okay, sometimes we get new hardware. That's great. And we can plan with that. We can design with that. But we have to live to the old world. So we planned, we surveyed, and we still see, okay, now we're covering 2 cars, 2.5. Then you optimize. Then you get down. This is how it could look like. Then we have the second problem. It's 80 persons in one train car. Do they have only one device? No. So we have 150 devices maybe. Would that be good for this lonely guy? Maybe not. So we need 2 access points in each coach. This brings us to spectrum. Which frequencies could we use? Is there enough spectrum? Or do we have channel utilization problems? Okay, somebody decided that we use channel 1, 3, and 6. You could do that, ends up in channel utilization 100%, with serving less than 10 clients. So your backhaul is no longer your problem. Your Wi-Fi is your enemy. If you clean it up, this is just an example. Yeah, the inner circle, we had 50% Wi-Fi doing Wi-Fi, no DHCP, nothing else. Then you clean it up, tune the data rates, and other stuff we all used to 5 to 10 years ago. And then it gets much cleaner, and then you get at least some throughput through the Wi-Fi to the uplink of the train. And then we come to the spectrum again. Basically, 2.4 is not really usable. Imagine 80 people, how many will use their AirPods in the train? What will happen? The AirPods will still work, but the audio quality on the AirPods is pretty bad. Bluetooth finds a way. So they not only complain about the Wi-Fi being bad, they complain audio is bad. Because the Bluetooth is bad, because the codec will change. Yeah, so it correlates each another. So 5 gigahertz, okay, we're not allowed to use DFS channels, happy. That's a great thing, so we have more or less 2 or 3 channels. That's it. So 6 gigahertz, I know the people in the US, you are not allowed to use it on trains, but we are. But we don't have hardware. That's the other problem. But 6 gigahertz could be the real game changer for Wi-Fi in trains. So this is how 2.4 looks in a non-crowded train car. It's not much people in there, because there's some technology using the upper part of the band. So would you use that? No. This is half-full train car, 5 gigahertz. Do you think this is usable if it gets full? Not really. Yeah? And these are just examples from, I don't know, 50, 100, 150 train rides. And this is not the worst case. So what do? We clean up the Wi-Fi, and then we come to the uplink problem. This is a solution, hybrid connectivity. We have low Earth satellite networks and 5G combined. This really works. Another solution, doing Wi-Fi at 60 gigahertz as a trackside solution. It's already in place in the US, it comes in the UK, it comes even more. That's a really nice solution. And then we have the other guy that says validation for security, for whatever, RF. Yes, this is how we do it. No, not really. Yeah, but this is how it could look like. Yeah, so this is how we do it. We take our survey tools in a train that does 166 miles per hour, because you don't have time to do it when it's in the standstill, because it doesn't have any energy if it's in the standstill. Yeah, so during the train is running. Thanks for the time.